Thank you all very much. Thanks for being here after lunch. It's always a tough spot, but I'm glad you guys are joining me here today. So I'm going to try and keep to time. I'll do my best to make sure that we can get through the content. But today, I'm going to be talking about leaked secrets and some experiments that we've ran to find millions of these credentials and other secrets in public spaces, specifically in public code repositories and code sources. So just quickly, I'm sure everyone's probably aware of this. I mean, we're at an API conference, and anyone that's dealt with APIs has probably dealt with API keys. But when I'm talking about secrets in software development, I'm referring to a broad range of credentials, like API keys, like credential pairs, database URLs, like security certificates, anything that you really don't want someone to have, anything that authenticates you, anything that decrypts information, basically anything that an attacker will really want to use. So this is kind of the broad term for secrets. And again, I won't spend too much time on this because I think everyone here is familiar, but there's been a shift in development and largely based around APIs. We no longer build monolithic applications. We build up applications that are a collection of different tools. So we might, use Okta as authentication. They're here. Maybe we're using a managed database. So we're using all these different tools because it helps us build our application faster. It makes it more secure in many ways. But it does mean we have to manage a lot of secrets. It's not just for our application. It's also for our infrastructure. Now that we're dealing with cloud infrastructure, testing tools, that whole DevOps element of development has really been decentralized. And again, we're using a lot of secrets for this. Once our application runs, then pesky marketing teams and sales members will want integrations into their tools, their dashboards, other areas like that. Again, more secrets. And of course, we build our own microsystems. We build our own endpoints internally, which also might leverage secrets. So what does all this mean? Is that every single one of these, this is an oversimplified version, but every single one of these logos, every single one of these icons is a potential attack vector, is a potential entry point into an attack for an attacker. And once you get into one, you can often find additional credentials. You might be able to elevate your privileges. You might be able to move laterally. So we can really start off an attack and sprawl it from here. So that's all I'll talk about, kind of what secrets are, and how we use them. So we've got lots of secrets. We don't want anyone to have them. We definitely don't want them to be in public places, and we don't want them to be in public source code. So I'm sure we can all agree on that. So let's look at one site in particular that we will base this presentation around, and that's GitHub. I'm sure everyone here is familiar with GitHub. In the rare case that you're not, every single one of your developers definitely will be. 90 million developers currently use GitHub. There's huge amounts of source code that is on there. A lot of it's public, a lot of it's meant to be public, and some of it is private, but accidentally is made public. So lots and lots of source code is in here. Last year, there was over 1 billion commits, 1 billion contributions were made to GitHub. So lots of information. So what we decided to do at GitGuardian is we decided to scan all of GitHub to try and find how much sensitive information is there. So throughout the year of 2021, we scanned said billion commits. If you pushed something public to GitHub, GitGuardian scanned it. So you might be wondering how we did this, why we did this. Is it illegal that we did this? Yes, all of the above is perfectly fine. And that's because GitHub has a public API. So if you've pushed code into a public repository, you may think, no one's ever going to find that. I know it. No attacker is looking at me and my shitty code to try and attack into my company or anything like that. That may be true, but your code will be published on the GitHub API. So anyone can go to this. So the API here is here. It's api.github.com/events. Every single thing that happens publicly on GitHub is pushed onto this API. And there's lots of different types of events that happen on this API, but there's a couple that we were interested into. The public event, which is when a private repository turned public. This is by far the most interesting because often along with it, a whole bunch of history becomes public as well. So if you've made a mistake in the history, now that is public. So something that happened a year ago, a developer leaks an API key on a development branch, that's now public, and also the push event. So this is the API here. I won't go into it, but what you should know is that anyone can view this API. You don't even need authentication. You can ping this 60 times in an hour without any authentication, and you can create lots of GitHub accounts if you need more than 60 pings. So the point that I'm making is that this is very easy. So we did it, but we know a lot of attackers did it. You can monitor this, you can leak a canary token, and then you can monitor the traffic that hits it, and it generally will start being pinged by bots in about a minute. So that's really quite scary. So our methodology for our research that we did in this covered 3 areas. The first one is we scraped the information from the API. So we have a complete record of everything that happened on GitHub throughout the entire year. The second thing that we did is we scanned it. We used 2 methods of scanning for secrets in here. Because one of the questions that will probably come up is, how do we find actual secrets? How do we know that they're actual secrets? So we built specific detectors for different types of secrets. We built out 350 specific detectors. So AWS had a specific detector just looking for AWS credentials and looking for the credentials that matched those patterns. We had 350 types of them so that we could detect them with a really high level of accuracy in there. But not all secrets can be detected with regular expression because some of them are kind of generic high entropy strings. So our second method was using entropy statistics and code analysis and combining those to try and pull out all other kind of secrets that we may have missed. 95% of high entropy strings on GitHub are not secrets, right? They're unique identifiers. So we have to analyze the code after we've found something interesting to make sure that it's an actual secret. So then we ended up with huge numbers of secrets, and we needed to strip this down a little bit to try and remove any false positives that may have passed through our gates. So then we did our validation stage, and we had multiple areas of validation, but here's 4 kind of main ones. Keyword elimination, trying to get rid of anything that has test in it, so we're not using any test credentials. We validated a lot of the API keys with the third-party provider. So I'm going to talk about cloud provider accounts that we found. All of these are not only real, they're valid. So we could check them with the cloud providers, ping that API, and make sure that they are actually valid keys. So that gave us really 100% accuracy with those, with many types of keys. We would group incidents so that if a key was leaked in a public project that was cloned all over the place, it didn't come up all the time. And then we'd alert and monitor. We alerted everyone when we found an API key. So you probably don't know, but the metadata of your commit has your email address in them. So we sent an email every time we found something interesting. And then we decided to monitor whether or not said credential found remained on GitHub. If it was removed in a couple of days, we had high confidence that that was a true positive that we had. So we monitored whether or not action was taken to remove that credential or invalidate it over the next days. So what did we find? So we found 6 million credentials in 1 year on GitHub. So that QR code gives me a backdoor into your... No, it doesn't. That QR code takes you to the report that we had if you want to find out, kind of go deeper into this. So what did we find? So 6 million credentials. We actually found that this was a 2 times increase from the previous year that we did this study. But this is a huge amount of credentials that we found. Now, some of these are obviously personal credentials to personal accounts. They're still highly sensitive. Some of them may be students using it. But we also found that a lot of companies' credentials were also leaked throughout this process. And we found that most companies' credentials weren't leaked on repositories that were owned by them. They were leaked on their employees' public repository, which is interesting because companies don't have authority to be able to implement security measures on what their employees do on their personal accounts. So really quite interesting that what we found here. So what are the different types of secrets that we found? Well, we found lots. The first category there, other, that kind of comes into high entropy strings or RSA keys or stuff that we don't know what exactly it does. But we know that there's secrets, we know that it does something, but we'd have to analyze the code to find out more. 21% of the secrets that we found in public code repositories were for data storage. So databases. That's huge. That's more than 1 million database credentials that we found in public spaces. Now, not all of those will be interesting, but I can guarantee that a lot of them will be. Cloud providers. So again, this is a category that we have 100% confidence in. Everything we found is real and valid. We found nearly 1 million cloud provider keys that were valid on public GitHub. You don't need to be a genius to know what you can do with a cloud provider key. You can launch an attack. You can scan, you can mine for cryptocurrency just to rack up a bill. Or if you're more malicious, you can enter in, move laterally, and do all kinds of malicious things. So lots and lots of different interesting ones. The last one here, version control platforms. This one's interesting because this is really, we've found the credentials to get inside your private repositories on your public repositories. So one of my favorite statistics in this, which I think is quite funny, is that we found 500 commit messages where the message was the authentication token for GitHub. So if you're not familiar with Git and GitHub, what this means is I've sent an email where the subject line is my password. Like, that's the exact kind of level that we're talking about. You're giving me access into your private repositories publicly, and your commit message is your authentication token. I think this clearly is just a misunderstanding of how authentication works on GitHub, but it happens. So it's quite interesting. We find these secrets everywhere. I won't go too much into the details. There was some positive takeaways here from this, particularly in cloud accounts. AWS we saw a decrease in, along with a couple of other cloud providers. This is a result of AWS taking good initiatives and some other providers, because what really happened is AWS generally has a policy that if a key is used for malicious purposes, they will revoke the bill. So if you get a $50,000 bill, AWS won't charge you for it, but AWS still has to pay for that. So it's no wonder that they've taken good action into kind of reducing that. But that's really where the positivity of this talk goes down. We also found it interesting that really, really new players had lots of secrets on the market. So PlanetScale and Supabase both launched last year. I think Supabase launched a little bit before last year, but PlanetScale launched mid last year. And immediately we started finding credentials on GitHub for these types of services. So you can kind of monitor the popularity of a cloud provider based on how many secrets are being leaked on GitHub, which I kind of thought was an interesting statistic that you could follow. Some other quick fun facts on the study that we did. Most people would assume that Mondays or Fridays, most amount of keys were leaked. It was actually on weekends. We relate this back to people probably working on personal projects outside of work where most of these credentials were leaked. But outside of weekends, the most popular times to leak credentials were public holidays. So, you can really start to see that when you remove someone from the bounds of a safe office environment or the restrictions that they have, mistakes start happening at an elevated frequency. And this isn't good news because it's not your organization's accounts. It's still giving attackers an attack vector, because getting into one of your employees' personal accounts, particularly GitHub or somewhere like that, I'm still going to be able to find lots of interesting stuff. For instance, perhaps some Slack tokens that I can launch internal phishing campaigns with. So lots of different interesting, but we can gain some insight based on when we start to find these secrets. Now, we also looked for secrets in other places. So we decided that we'd also look at Docker. So if you don't know, Docker is like a mini virtual machine. It's basically, if you want an application, you can ship your application along with everything else that needs to run in a nice little container. It's very, very popular. There's over 9 million Docker images available for free publicly. Most companies, a lot of companies use Docker to ship their applications. And I wonder how many Docker images contain secrets. So when we started pulling apart Docker images, we actually found that nearly 5%, so a huge number, 5% of Docker images contain hard-coded secrets. So this comes from the fact that when you kind of pull code into a Docker image, a lot of people think that this is a black box because it gets obfuscated, it's hard to examine. But if you have secrets in your code, you're going to have secrets in your Docker image. If you put them in your Docker file, when you build your image, even if you delete them later, Docker has a history. Layers can be thought of like Git history, where if you make a mistake and you do it later, it's still going to be in there. So huge amounts of secrets. We scanned 10,000 images, and in total we found 4,000 secrets, and just over 1,000 of those were unique secrets. So a lot of duplicates there, but a huge number. If you're an attacker, you pull down 100 images, you know, 4 or 5 of those are going to contain secrets. It's not a huge amount of effort to do to find something interesting in there. And the last area that we looked at were private repositories. So we are a code analysis company at GitGuardian, so we were able to analyze the code of a lot of our large enterprise customers. And what we found was really kind of quite shocking. At the time that we first scanned for secrets, we would find about 13,000 in your typical company. So your typical company that we had is with 400 developers, some with more, some with less, and would typically find about 4 AppSec engineers in that company. So 1 to 100 there. Out of those 13,000 total secrets that we found, just over 1,000 of them were unique. So this is quite scary because you may think that it's because your code is private, that it's safe, but private code is horrible at staying private. Really horrible at staying private. I'll show some examples quickly at the end of when that's happened. But basically, it doesn't have the authentication layers and the logging to be able to store sensitive information in there. So 1,000 unique secrets in your source code means that if an attacker gets into your source code is leaked, one of your developers commits their authentication token in their commit message, then you have multiple entries for attackers to be able to find API keys and abuse your systems. So this is just kind of a graph of showing the same amount of code publicly and internal. This is what we find. Way more secrets internally per commit than what we found publicly. So very quickly, I only have a few minutes left, but I wanted to kind of leave you with this research with some real world examples. Very well that this all happens. Yep, secrets are bad. They're in public spaces, blah, blah, blah. But does it actually happen? Have attacks happened because of this? Yes, all the time, actually. I'll go through a couple of bad ones, but there's plenty more that I can discuss after. The first one is CodeCov. CodeCov was a code coverage tool. It sits in the CI/CD pipeline, that continuous integration, continuous deployment, and it basically tests how much of your application is being tested. It did a specific job. It wasn't something you'd classify as a really critical application, but it was in your CI/CD environment, which meant it had access to your testing environment variables. Or at least I hope it was your testing environment variables, and you've at least separated production from development credentials, which isn't always the case. So what happened? They had a hard-coded secret in their Docker image, their public Docker image that anyone could have pulled down. This secret gave attackers access to code, where they could write code. They injected a malicious line of code into a bash uploader script. It was a big file with thousands of lines of code on it. And this script did a specific thing, which was say, hey, dump out the environment variables, send them to me. What the attackers were after is the credentials into private Git repositories. So 20,000 customers were using CodeCov. A lot of predominant names were in there, like Rapid7, Twilio, HashiCorp. And basically what happened is that the attackers were able to enter the private repositories of those 20,000 CodeCov customers, because in the 3 months that the malicious instance was there without them noticing, all of these companies had their private repositories breached. So this is an example of where a hard-coded secret starting from Docker can end up with an attacker inside your internal code repositories, where we just discussed you probably have 1,000 secrets. So you're going to have a bad day if that's the case. So that's one example that we did. The other one, talking about private source code as well, is that this year we've had multiple leaks from that. So my time's running up, so I'll finish up quickly on this. But with the Lapsus group, they rose to prominence. They leaked a lot of incidents. So Twitch is one of those. We actually scanned Twitch's source code and found 6,000 secrets inside it, 6,000 repositories they had. So this just shows that the 1,000 secrets that we discussed earlier is pretty conservative in a real-life example. So I'll skip past these because my time's up. I tried my best. But some leaving thoughts with you. is basically don't put credentials in Git. It comes down to that. Try and detect them where you can, use short-lived credentials, and restrict your API scopes. Just because someone has access to an API doesn't mean that you need to give them access. You can limit the range that it has on there. So here are some just some resources while I finish up. The state of secret sprawl on the right is the report that I kind of just ran through. That will there, but there's also a maturity model that we have put out for managing secrets. If you want to know how you should actually manage secrets in your organization and give yourself a benchmark, then you can use this one here. My time's up, but thank you very much for listening. I hope you found it interesting. Okay, oh yeah, I have 5 minutes for questions. Yeah.
How could I perform a self-test of my repositories? Is there anything you put publicly, the way you tested public repositories? And then how could I fix it, maybe?
Yeah, great question, because I can plug my stuff. So Git Guardian, we have scanning tools for it. So we have free tools. We have an open source project called GG Shield, where you can scan your internal repositories, but we also have a dashboard that you can plug into your repositories. It will give you a full report on that. If you just want to kind of give yourself a benchmark, find out if you have a problem, then we have the 30-day free trial from all the business enterprise customers that you can give yourself a benchmark with, or you can use the open source tools to try and discover. So yeah, GG Shield, Git Guardian is really a great way to kind of test your environments to try and find secrets in there.